derivative formulas. We've learned a lot between test 1 and this upcoming test 2. So today we're going to practice with our derivative formulas. But I just want to remind you, your pipeline project and your drum project are due today. But the policy is if you hand it in one class late, 5% penalty, and within a week after the due date, 10% penalty. So if you hand it in Friday, lose 5%. Hand in Monday or Wednesday, you lose 10%. So because those are relatively small deductions. And so if you have like a big chunk not done, like a 20-point question not done, it's probably more worthwhile to hand it in late and complete than to hand it in today and on time. Okay. All right, so let's have a quick look at this strategy guide for differentiation. How many of these can you fill in? Ready? 30 seconds. Fill in as many derivative formulas as you remember. All right, so let's fill them in together. What's the derivative of x to the n? N x to the n minus 1. That's the only one we had for test 1. That's the only derivative rule we knew for test 1. The rest of them we've learned since then. Some of them we kind of had an idea of, we kind of guessed what they were going to be, but now we officially know the derivative of e to the x is e to the x. Derivative of a to the x, a to the x times the ln of a. Derivative of sine x, cosine. Derivative of cosine, negative sine. Derivative of tangent, secant squared. Derivative of ln, 1 over x. Derivative of arctan x. And the derivative of arcsine. Like that? Yeah, I think that's it. I remember. That's it. Okay, good. Okay, so those are our derivative formulas. Those are the only ones we know so far. If a function doesn't look exactly like one of these, you can't use these formulas, right? So if it's a product of two functions or a quotient of two functions, or a composition of two functions, we have a special rule for it, right? So if it doesn't look exactly like this, you have to use another derivative rule to break it down into something that you can use these rules on. All right, so remember sum and difference rules, really straightforward. If you want to take the derivative of a sum or a difference, you just take the derivative of each piece separately, add them together. Constant multiple rule. The derivative of c times a function is c times the derivative of the function. So constant multiples, that coefficient just like comes along when you take the derivative. Yeah, if you use the product rule on c times f, you'd have, right, c times f, you'd have first times the derivative of the second plus the second times the derivative of the first, but the derivative of the constant would be 0, so that term would just go away. So you can use the product rule on that in that case, but you don't need it. So the product rule you use if the function you're looking at consists of two functions multiplied together. Couple of cautions. Remember that the derivative of f times g is not f prime times g prime. You have to use the whole product rule. An expression like the cosine of 3x is not multiplication, right? 3x is the input into the cosine function. And if there's a product inside the function, you have to use a different rule before getting to the product rule. We'll do some examples. All right, and then we have the quotient rule. The derivative of f over g is denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Always remember that the derivative of f over g is not f prime over g prime. And then we have the chain rule. The derivative of a composition of two functions. You take the derivative of the outside function, evaluate it at the inside function, times the derivative of the inside function. if there's a composition inside a product or quotient, use the product or quotient rule first. So here are some examples. I won't go through all of them, but these are examples, particularly these last three, pretty complex examples of using the chain rule and the product or quotient rule. All right, we're going to do a couple of tough examples together, complicated looking things, and then you are going to spend the remainder of class working on a big assignment. Your next homework assignment is numbers 1 through 73 odd, which is a lot of derivatives, so you're going to spend the remainder of class on that today. And I can project those if people don't have books. But. Okay, so we'll do two together just to have a model, and then you'll get to work. Okay, so g of x is the square root of 2 to the x ln x. So what do I start with? That is the square root of 2 to some stuff, right? So what is the derivative of the square root of 2 to some stuff? Square root of 2 to the stuff, yep, times the ln of the square root of 2 times what? The derivative of the stuff, which I'm not even going to try to do right now because I know that taking that derivative is going to be a little work because it's a product. So I'm just going to write times the derivative of that, and I'll take the derivative in the next step. So when you have really complicated derivatives that use a lot of chain rule, I find this to be really helpful so that I don't lose track of what I've already taken the derivative of and what I haven't. So at this point, I've just done the derivative of the outside function. Square root 2 to some stuff, its derivative is square root 2 to the stuff times the ln of square root 2. Then you still have to multiply by the derivative of the stuff. So in my next line, I just copy the stuff that I've already done. And then I start working on the derivative of x ln x. And what rule do I have to use to take the derivative of x times the ln of x? Product rule. X times the ln of x, that's a product. So I have first times the derivative of the second. What's the derivative of ln x? 1 over x. So first, I didn't change anything at all. The first function in this product is x. Just copy that down. Times the derivative of the second. The derivative of ln x is 1 over x. Plus the second times the derivative of the first. And what's the derivative of the first function in this product is 1. And then x times 1 over x is 1. So I'm just going to do like one small simplification. On your test, I believe when I asked you to take derivatives, I just wrote do not simplify. So you could just circle that and be done. And if you leave the 1 out, that's fine. Yeah. Yeah. It's hard for me to leave that unsimplified when I can simplify it in one quick step. Yes, yeah. So I would still use the product rule on x ln x, and then if there was a plus, plus x squared, the derivative then would just be plus 2x. Any questions on this? All right, let's do another one. E to the cosine of the ln of x squared plus 1. So that is e to a whole bunch of stuff, right? So what is the derivative of e to a whole bunch of stuff? E to the whole bunch of stuff, so I'm just going to copy this down, cosine of the ln of x squared plus 1. So e to some stuff, its derivative is e to that stuff times the derivative of all that stuff, the cosine of the ln of x squared plus 1. So I didn't even try to take that derivative in my head because it's too complicated. So I just wrote down times the derivative of all that stuff. So then I move on to another line and I say, okay, copy down what I've already got, the cosine, e to the cosine of the ln of x squared plus 1 times. Now I work on taking the derivative of the cosine of the ln of x squared plus 1. So the outermost function at this point is cosine. That's the cosine of some stuff. What's the derivative of the cosine of some stuff? Negative sine of that stuff. Times the derivative of the stuff, which in this case, stuff is the ln of x squared plus 1. Yep. But I'm not going to actually write that down till the next line. Okay, so now I just copy down what I've already done. Kind of moving left because I'm running out of room. Each time I take a derivative, it takes up more space. I'm going to put the negative out front here. So this just becomes times the sine of the ln of x squared plus 1, just copying down what I already have, times, now I work on taking the derivative of the ln of x squared plus 1. So the derivative of the ln of some stuff is 1 over that stuff. So this is going to be times 1 over x squared plus 1 times the derivative of the stuff, which is 2x. And that one I can do in my head, right? So you don't have to write times d dx of x squared. If you can take that derivative real fast, go ahead and do that. So there it is. No. The only simplification that would be really obvious is to do the 1 times the 2x and write that as a single fraction. With the 2x over x squared plus 1. But doesn't matter. So to get really comfortable taking derivatives, you just have to do it a lot. So start practicing.